f of a. And you know how to do the antiderivative, right? Okay, so how do you do the antiderivative? Let's let u equal 7x. du be 7dx. So 1/7 du. What did we do that? So this is an integral, and notice I'm leaving the limits off for now because those limits are x values, right? They are not u values. That's something you'll learn how to do today. For now, they're x values. I'm just going to pretend they're not there for just a minute until I get the correct antiderivative in terms of x. This would be 1/7 to the u, which would be 1/7 e to the 7x from 0 to 1. And so if I plug in 1 into that, I get 1/7 e to the 7th. What? Anything to the 0 power? 1. So I get 1/7 e to the 7th minus 1/7. So that would be the answer. Any questions about that? Okay, number 2 is pretty tough. Why is number 2 pretty tough? Okay, I have to split it apart. Now, before I do that, check and make sure tangent is not the antiderivative of anything. It's not. But make sure it's not. Do you know what I mean by that? How many of you sat way too long and hard on the ones that were secant tangent or secant squared? Don't know what I'm talking about? Why are those quick and easy? Tangent squared is the derivative of, or secant squared is the derivative of tangent, and secant tangent is the derivative of secant, right? So if you come to one that's already one of your rules, it's a little easier. This one's tough because it has sine and or tangent is not an antiderivative of anything we know. So we got to break it up into sine plus. So I'm going to let u be the denominator. That way the sine will cancel. I am going to have to work with the 2x either in my brain or I'm going to have to do a u substitution twice. And there's 2 ways you can do that. I would probably rather just deal with it in my brain. You know what I mean to that? So we'll see how that works. So I'm going to let u equal cosine 2x. du will be negative sine of 2x times 2 dx. Good so far? So I get 1 over negative 2 sine of 2x du dx. So I get the integral of sine of 2x over u times 1 over negative 2 sine of 2x. I said that actually the 2x cancels itself out. So I get negative 1/2 integral of u to the negative 1. So it's where I got the u to the negative 1. That problem on last night's homework that the e to the u had the negative in front and it ended up in the bottom is because it was e to the negative u because it was on the bottom. What is the antiderivative of u to the negative 1? Tricky question, isn't it? And that's a lot. And then u was cosine of 2x. So B. So yeah. Okay. So today we're going to learn how to deal with substitution with limits. We did one on the over here with the e to the 7x, but there is a faster way to do it. Now, a lot will test it. So for today, you have to do it this way. Now, after today, on a problem that you don't have to do it this way, I don't really care how you do it, but you know that AP will test this specific skill. Even though we can do it like we did it on the bell ringer, AP will test to see if you can do this. And I will show you how they'll do that in a couple of slides. So the steps for substitution with limits. Starts out the same. Find u, find du, solve for dx, substitute in u, du, and x and dx. All of that's the same. Step 6 is new. We are going to change a and b, the limits, from x values to u values. I'm going to show you how to do that. And then you do the integral, and you leave it in terms of u, and you anti-differentiate and do f of b minus f of a. I don't have to, on a definite integral, I don't have to switch back to x's, and I'll show you what I mean by that. So this is a little slicker. It is something that y'all will fight against because the other is a little bit more intuitive. I know I did when I was in calculus. I wanted to do the way on the bell ringer every time, and I would, it's like, no, don't show me the other way. I don't care. But again, AP will test this skill, and I have an AP problem to show you that on a couple slides from now. I'll show you when we do number 1 down here. What number are we on? Okay, let's look at that next, or that first problem. Just like yesterday, what is a good u for this problem? 4x minus 5 is a wonderful u. Du would be 4 dx. So 1/4 du would be dx. So my integral is u cubed times 1/4 du but those integrals are not equivalent unless I change the 1 and the 2 as well. Because would you agree that 1 and the 2 are x values? It's from the x equals 1 to x equals 2. Well, if I go back and plug 1 and 2 into this equation, and I find out what they would be in terms of u. So if I plug in 1, 4 times 1 is 4. Negative 1. Everyone see where I'm getting that? And then if I plug in the 2, I get 8 minus 5, which is 3. The beauty of doing that is I never have to go back to that original equation. This is a completely equivalent integral. I can work with this definite integral and never go back to x's. It gives me the exact same thing as I would get if I did go back to x's. Does this make sense? So let's walk through it and I'll show you why it works. Okay. So I get 1/4 times 1/4 u to the 4th from -1 to 3. If I write this integral down with the 1 and the 2, it is an incorrect integral. Does everyone know what I mean by that? If for some reason you decided to work the way on the bell curve, you leave the 1 and the 2 off. You put them back in later. Does everyone know what I mean by that? Because that is an incorrect statement to put the 1 and the 2 down. Any questions about the antiderivative there? I have 2 1/4 because I raised the power to the 4th. Now, the beauty of this is to finish it, I plug in the 3 and I plug in the -1 and I'm done. I don't have to go back to x's. Now, let's just play it out. If I did plug in the x's here, you'd have 4x minus 5. And I'd plug in the 1 in and the 2 in. And what do I get if I plug in 1 and 2 into 4x minus 5? -3 or -1 and 3. So you see that it's just done that step already. If that makes sense, it's just already done that step. It's plugged it in, taken care of. So I get 1/16 times 3 to the 4th minus 1/16.
So then why would they care if you did it with like the 1 and the 2?
They don't if you are just picking. Now, the one thing they will care about is if you say these are equal, but you have this as 1 and 2 still, because that's not equal. You know what I mean by that. Now, if you side note, work it out, and go back and substitute it in, they'll be fine with it. If you go from 1 to 2. But they will ask questions that make you do this. But as far as just an integral, if you work it the other way, they won't care. But I will show you a problem that they will force you to do it this way.
So what is the condition you have to do it that way?
Hey, I'll show you the problem. Right now there's not. These you could do the other way. But AP has this problem set they ask. That if you don't understand this, that you'll miss it. That being said, as long as it's a regular integral, you'll get the same answer either way. As long as it's not an AP question. But just know they will ask. Again, I'm going to practice this way. So for tonight's homework, I want you practicing this way. Even if later you decide you don't want to do it this way, that's fine. I just want you to practice this way to make sure you understand it. That makes sense? Do you have a question? You sure? Is it on the next one or the one before? Okay. Okay, what's a good U on the next problem? On my what's the U? Negative 2R, dr. Is that a good thing? Yeah, because the R's are going to cancel. That's good. Good use. So I have the integral. Oh, sorry. -1 over 2R. So I have the integral of R times the square root of U times -1 over 2R du. And set it from 0 to 1. Where is this from into? What do I get if I plug in 0? 1. Easy y. 1 minus 0, or 1 minus 0.
But isn't, oh, we're plugging into U, not the, I was plugging in the actual equation.
Because you're changing the x's to u's. And then plug in 1 and I get 0. That's a little strange because those are backwards, but it is what it is. I'm just switching those variables out. I leave it however it ends up. The r's cancel. So I get the integral from 1 to 0, 1/2 u to the 1/2. Any questions so far? No, because the square root of u was on the top.
Outside of it.
On the outside.
Oh yes, thank you. You're right. again, 0 to any power is 0, and then times anything is 0. 1 to any power is 1, sine of 0 minus negative 1 half 2/3. And I wrote all of that out to make sure you get the signs right. Minus and negative makes a plus, so I get 1/3. Again, it kept me from having to plug the 1 minus r squared back in. All of that. Any questions about that? Okay. Because I know this is your biggest question, let's do the one on the right first. Why do I have to know how to do it this way? Both of these are real AP problems. The problem on the right is a very, very easy substitution problem. If you know how to change limits. But as you can imagine, most people on the AP exam miss this because they don't know how to change the limits. Again, this is a real AP problem. This is not the only one of its kind. They show up all the time. If you were working this problem, you don't know what F is, but if whatever it was, what would you do with the 2t? You would do a U substitution with the 2t, wouldn't you? So you would let U equal 2t, and du would equal 2dt. So 1/2 du would equal t. So a lot of people really quickly do this and insert A. And you notice they put it first, so you try to pick that one. Why is A wrong? They left it from 4 to 8. Those are not completely equivalent integrals if you leave it from 4 to 8. What would those values be? 8 and 16 if you multiply by 2. That's not a hard problem. Again, if you know how to change the limits, it is not bad at all. But it comes up a lot. Start that in your notes, you will see something like that again. So it's a U substitution problem, getting rid of the 2t. And you could probably tell it was a U substitution problem because they didn't even try, they even used U, right? They were showing you, I'm doing U substitution. What is an equivalent interval? Okay, the one on the left, I want you to get your calculator out and explore this one for a moment. You have never seen a problem like this before. It is trying to trick you. I will warn you of that. Oh, don't do the intervals. Just type it in. Just type in a function in y equals and look at it. 1 divided by 1 minus x. Type it in y equals and look at it. And you tell me what is the area underneath it. Don't even do it with an integral. Just look at it. Would you agree that's a problem? Someone tell me why it's a problem. Why can you not do it? Okay. When we learned the fundamental theorem of calculus, the f of b minus f of a, someone go back and read that. Read that theorem. The one that gives you f of b minus f of a. I think that was the second one we did. Okay, stop. Read that louder. One more time. piecewise function with a break in it. You could integrate from 0 to the break and then the break to the next piece. Does everyone know what I mean by that? You could just integrate it in two separate pieces. But because this goes to infinity at the break, we're out of luck. There's nothing we can do. It's divergent. Now, you can imagine this was an AP problem. How many people missed that problem? Most all of them. What do you think they put? They did a U substitution, right? And they did f of b minus f of a. Notice b is 3 and a is 0. Where is this function not continuous